All right, now that we've had plenty of practice with solving equations, we're going to move into this idea of what's called a literal equation. Okay, so first off, the definition of that, a literal equation is simply an equation that has multiple variables. Okay, so far the equations we've been working with have been like solve for x or solve for y or solve for z or whatever it is. It's usually just one variable. So now we're getting into equations that have multiple variables, and you got to pay attention to what the question's asking you to do. So for example, if I were to write this equation down, 3y plus 4x equals 9, okay? Now, the question can go one of two ways. They could say solve for y, or they could say solve for x. Okay, both those are viable questions. Okay, so make sure you guys just are paying attention to what the actual question is asking you to do, because it could be either one. Okay, sometimes it's better. Sometimes they want you to solve for x for a particular reason. Sometimes they want you to solve for y. Okay, so let's say the question was solve for y. So let's say we're going with this question over here. Okay, so the question is solve for y. Let's go and rewrite it down here. So 3y plus 4x equals 9. Okay, so the idea is that you want to get the y by itself. So you want to keep this, but you want to get rid of everything else. Okay, so you want to get rid of that 4x and you want to get rid of that 3. Okay, now you're going to treat it the same way as you did with the other equations. You're still going to move things around by doing opposites, right? Opposite of addition is subtraction, opposite of multiplication is division. Okay, so let's go ahead and draw that line. I still highly recommend draw this line where the equal sign is. That way you clearly see left side and right side, especially as we get into the more complicated questions. Okay, so looking at this question, we were trying to keep the y, but get rid of everything else. Okay, the advice I gave you guys in previous videos still applies. Whatever's attached to the piece that we're solving for, I would save that for later. So let's save that 3 for later. Let's get rid of that 4x. Now, previously, we would want to keep the x and get rid of just the 4, so you would be dividing. But in this example, because we're trying to get rid of that entire chunk, we want to get rid of this as an entire piece. Okay, so we're actually going to be adding or subtracting it to the other side. Now, it's positive, so to move it, we will subtract it over to the other side. Now, the problem is, on the right-hand side, there's no other x terms. So I don't want to line it up with that 9, so I'll put it off to the side over here. Okay, because I cannot combine the 9 and the 4x. Okay, they don't go together. Okay, so here's what happens. Draw the line across. So leftovers, we still have that 3y. Okay, and then because we cannot combine the 9 and the 4x, we're just going to write them out next to each other. Now, it doesn't really matter the order of which it goes. Typically, the variables always go before the numbers, so it's sort of better to write it like this. So negative 4x, and then that 9 was a positive, so we'll plus 9. But see how we can't combine those? All right, those are not like terms, so we cannot combine them. Okay. All right, now we need to get rid of that 3, but we want to keep the y there. Okay, so just like before, when you're solving equations, if you want to keep one piece of it but get rid of the other and they're attached like that, you have to get rid of it by dividing. Okay, so we're going to have to divide by 3. Okay, now because we divided by 3 on the left, we have to divide by 3 on the right. Now when you divide the entire side, you have to divide each individual piece. So you have to divide this by 3 and this by 3. You have to divide everything. Okay, and then we can simplify. These 3's cancel each other out. Remember, whenever something appears on top and bottom of a fraction, they cancel out. And we get our answer of y is equal to, now the 4 over 3 does not divide out nicely, so leave it as a fraction. That's not a big deal. So negative 4/3 x. And then the 9 over 3, that does work out nicely. 9 divided by 3 is perfectly, it divides to be 3. And then we're done, right? The question said solve for y, and we now know y is equal to all of this, okay? But see how our answer has variables in it? So that's the challenge with these literal equations, okay? Now, you could have easily asked the other question on the right over here, where it says solve for x. I could have easily said solve this equation for x. You would do the same thing, but except you're trying to get the x by itself instead of the y, okay? So that's what these literal equations are all about. They get a little bit more challenging when they throw in more variables. So let's actually try one of those. Okay, so let's say I give you this equation. And let's say the directions are solve for k. All right, and your equation is this. 3 plus 5x minus 5, oh sorry, not 5, minus kx is equal to y. All right, so now this one's a mess because there's 3 different variables going on. There's x's, there's y's, and there's k's. Okay, that's why I make sure you just pay close attention to the actual question. It says solve for k. Okay, so we want to keep this piece and get rid of everything else. Okay, which means we have to get rid of that 3, we have to get rid of that 5x, and we have to get rid of that x that's attached to the k. All right, so let's do that one at a time. 3 is pretty easy. We can do that pretty easily. It's a positive 3, so we'll subtract it. Oops, let me switch to a pen. We'll subtract it to the other side. Okay, so subtracting 3 there. Again, I don't want to line it up with the y because I can't combine them. So let's put it off to the side over here. Okay, line across. Okay, leftovers. These are gone, but we still have that 5x minus kx. Okay, and over here on the right, we have y and then minus 3. Okay, so now we need to get rid of that 5x. Remember, we want to get rid of this entire chunk. Okay, it's a positive 5x. So again, we'll just subtract that entire chunk to the other side. So minus 5x. And again, over here, there's no x's on the right. So again, I'll just put it off to the side over here. Minus 5x. So be very careful. If you don't have like terms, you cannot combine them. So these cancel out. Bring down, we still have negative kx is equal to, and we'll just write this out in one long line. Y minus 3 minus 5x. Okay, we're almost done. Now we need to get rid of that, we need to get rid of the negative and the x that's attached to that k. Okay, now we're used to seeing this. You don't have to write this down, I'll erase it in a second. But we're used to seeing like this, where if you want to get rid of that 5, you would divide by 5. Same thing applies to this. If that was rearranged, if it was this x5, and you'll never see it written like that, but you could do the same thing to get rid of that 5. You could still divide. They would still cancel out. So same thing applies in this question. Let me go ahead and erase this so I don't confuse anybody. So we want to get rid of that x and that negative, but we want to keep the y. So we're going to do the same thing. We're going to divide by the parts that we don't want. Okay, we don't want the x and we don't want that negative. Okay, so again, after that, you have to divide every single piece by the same thing. So we have to divide this by negative x, this by negative x, and this by negative x. So you see how this is getting a little bit complicated. Okay, that's why this structure is very important. I still recommend drawing that line so you can see the left side and the right side very clearly. Okay, let's go through what happens. So on this left-hand side, these negatives cancel each other out, and the x cancel each other out. So we're left down to k, which is what we wanted. Okay, let's start off with the first piece. We have y over negative x. Okay, that doesn't simplify to anything, right? So we can't reduce that. So we'll leave it as a fraction. So it's negative y over x. The second piece, 3 and x's don't simplify at all, but we do have the negatives, negative 3 and negative x, so those negatives do cancel each other out. So it does become a positive 3 over x. And then the last piece, again, we have a negative and a negative, so those negatives cancel each other out. But then we also have x's on top and bottom, so those also cancel each other out. So we're left with just a positive 5. Okay? And as weird as and as ugly as that looks, this is your answer. Okay, the question said solve for k, and we did that. K is equal to negative y over x plus 3 over x plus 5. It's a weird answer, but that is how it works. Okay, so you can see how it gets a little more complicated the more variables we have. Okay? All right, let's go ahead and have you try one on your own. Okay, so I want you to try. The question is solve for x. Let's say your equation is 20 equals 8x plus 4y. All right, go ahead and pause the video, try it on your own. Don't be afraid to make a mistake, and then when you're ready, go ahead and press play to check your answer. All right, so hopefully you have already tried it, and we're just going to go kind of quickly through it. So the question says solve for x, so this is the part we want to keep. Okay, so we'll start. Let's get rid of that entire 4y chunk. So we're going to subtract it to the other side. Again, I'm not going to line them up because I can't combine 4y and 20. So these are going to cancel. On the right side, we still have that 8x. And on the left side, we have a negative 4y plus 20. Now I want to keep the x but get rid of the 8. So let's go ahead and divide by 8. And again, when you divide in one spot, you have to divide everywhere. So you divide this by 8 and this by 8. Okay, on the right side, these 8's cancel. And we do get x by itself, which is what we wanted. Okay, now these fractions don't divide perfectly, but they do reduce. So you do have to reduce your fractions. Okay, so 4 over 8 does reduce to 1/2, or negative 1/2 in this case. So negative 1/2 y. And then 20 over 8, you can do off to the side if you want to see it. Okay, those both reduce by 4. So let's divide by 4, top and bottom. So 20 divided by 4 gives you 5, and 8 divided by 4 gives you 2. Okay, so 20 over 8 reduces to 5 over 2. So plus 5 over 2, and then we're done.